Look around you right now. A circle, a wheel, a coin, a clock. Every single one of them is hiding the exact same number. It never ends. It never repeats. And humans have now calculated it out to over 100 trillion digits for a number that shows up almost everywhere in the universe. This is the story of pi, where it actually came from, why one obscure Welsh school teacher gave it its name, and why it keeps turning up in places that have nothing to do with circles at all. 4,000 years ago, Babylonian mathematicians were already estimating the ratio of a circle's circumference to its diameter, landing on about 3 and 1/8. Egyptian scribes working out the area of circular fields arrived at a slightly different value, close to 3 and 1600ths. Both were useful. Neither was exact because pi cannot be exact. The first real breakthrough came from Archimedes of Syracuse, around 250 BC. Instead of measuring circles directly, he trapped one between two polygons, one drawn just inside it, one drawn just outside. By doubling the number of sides again and again, all the way to a 96-sided polygon, he squeezed pi between two fractions, 223 over 71 and 22 over 7. He never wrote down a decimal. He proved a boundary, and it held for 1,800 years. Around 480 AD in China, the mathematician Zhu Changzhai pushed pi to 7 correct decimal places using that same polygon method, a precision Europe wouldn't match again for almost 1,000 years. He also found a simple fraction, 355 over 113, that's still accurate to 6 decimals, and is still used as a shortcut today. In the late 1500s, a German-born mathematician named Ludolph van Ceulen became obsessed with pushing Archimedes' method even further, using polygons with literally billions of sides, calculated entirely by hand. He spent most of his adult life on it, eventually reaching 35 correct decimal places. When he died in 1610, his students had those 35 digits carved directly onto his tombstone. For most of that history, the number didn't even have a symbol. Mathematicians just wrote out the entire phrase, the ratio of the circumference to the diameter, every single time. In 1706, a largely self-taught Welsh mathematics teacher named William Jones started using the Greek letter pi as shorthand, likely from the word for periphery. Almost nobody noticed. It took the most prolific mathematician in history, Leonhard Euler, adopting the symbol in 1737 and using it constantly for it to finally stick. Even then, it wasn't universally standard until the 20th century. In 1761, Johann Lambert finally proved what mathematicians had long suspected. Pi is irrational. Its decimal digits never settle into a repeating pattern ever. In 1882, Ferdinand von Lindemann went further still, proving pi is transcendental, meaning it can't be the solution to any polynomial equation with whole number coefficients. That single proof also ended a 2,000-year-old obsession. It is mathematically impossible to square the circle using only a compass and a straightedge. By the mid-20th century, mechanical calculators pushed pi past 1,000 digits. Then in 1949, the ENIAC, one of the first electronic computers, calculated over 2,000 digits in just 70 hours, a task that would have taken a human an entire lifetime by hand. So pi measures circles. That part makes sense. What doesn't make sense at first is why the exact same number keeps showing up in problems that have nothing to do with circles. Drop a needle onto a floor of evenly spaced lines, over and over, and count how often it crosses one. That probability experiment, first described in 1777, converges on pi purely by chance, with no circle anywhere in sight. The bell curve, the single most important shape in statistics, the one behind test scores, height distributions, and measurement error, has pi built directly into its formula. Nobody drew a circle to get there either. Pi governs the swing of a pendulum, the vibration of a guitar string, the way light and sound travel as waves. Anything that oscillates, rotates, or repeats in a cycle tends to drag pi along with it. It's sitting inside Einstein's field equations for gravity, inside Coulomb's law for electric charge, inside Kepler's law for planetary orbits. Pi isn't really a fact about circles. It's a fact about anything that curves, cycles, or spreads outward evenly, which turns out to be most of physics. Even in pure number theory, with no circles or waves anywhere nearby, pi refuses to stay out. In 1735, Leonhard Euler solved a problem that had stumped mathematicians for decades. Add up 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared forever. The answer turns out to be pi squared, divided by 6. As of the most recent public record, pi has been calculated to over 105 trillion digits, using cloud computing that took months to finish running. And yet NASA's Jet Propulsion Laboratory uses only about 15 digits of pi for its most demanding spacecraft calculations, enough to compute the circumference of the entire observable universe, accurate to the width of a single hydrogen atom. The current record for reciting pi from memory belongs to Rajveer Meena, who correctly recited over 70,000 digits, blindfolded, over nearly 10 straight hours. Buried in that infinite string of digits, starting at position 762, there's a run of 6 nines in a row, a coincidence so oddly specific that mathematicians nicknamed it the Feynman Point. Pi Day itself, March 14th, written 3/14 in the U.S. date format, was invented in 1988 by a physicist named Larry Shaw at a science museum in San Francisco. It happens to also be Albert Einstein's birthday, and decades later, the day Stephen Hawking died. One popular claim says the Great Pyramid of Giza encodes pi in the ratio of its perimeter to its height. Most historians consider that a coincidence, not evidence the ancient Egyptians knew pi as a precise constant. And here's the part that's still technically unproven. Mathematicians strongly suspect pi is what's called a normal number, meaning every digit and every sequence of digits appears infinitely often, with no pattern and no favoritism. Nobody has ever managed to prove it. Pi isn't just a number you memorize for a geometry test. It's a signature that shows up anywhere something curves, cycles, or repeats, a fingerprint of the universe's shape that was first spotted in circles almost 4,000 years ago and is still turning up in equations nobody has finished writing. We can calculate it to 100 trillion digits, and we will never, ever reach the end of it. Every video on this channel is built around one idea, one pivotal moment that quietly changed everything, explained clearly in under 15 minutes. If that's useful to you, subscribing means you don't miss the next one, and there's always a next one. And if this video changed how you think about something, even a little, hitting like is what tells YouTube to show it to someone else who needs it too. If this one was worth your time, there's another turning point video waiting for you right there.